Yo, what is up, guys, and welcome to another lesson. In today's lesson, you are going to learn how to convert recurring decimals into rational numbers or fractions. A recurring decimal is a decimal number that has a repeating single digit. For example, 0,3333333 to infinity. Or we can represent this number as 0,3 with a dot on top of the 3 to show that the 3's are repeating, or we can use the bar. So today we're going to learn how to write this number as a rational number or a fraction. The other type of a decimal number is the one that has a recurring pattern of multiple digits. For example, 0,181818 to infinity. Or we can represent this number with a dot on top of 1 and 8 to show that the 1s and the 8s are repeating. Or we can simply use the bar. When the decimal is a recurring decimal, a bit of more work is needed to write the fractional part of the decimal number as a fraction. Without any further ado, let's jump right into it. Suppose you are told to write 0,3 with a dot, meaning that the 3's are repeating in the form of a over b or a fraction. So how do we convert this number? Step 1, you are going to define an equation. What do I mean by defining an equation? You are going to let x be 0,33333 to infinity. Step 2, because there's only one single digit repeating, which is a 3, we are going to use what we learned in our previous video, which is the powers of 10. Remember that one digit is 10 exponent 1, and two digits will be 10 exponent 2, and three digits will be 10 exponent 3. Therefore, we'll multiply both sides by 10, right? So 10 multiplied by x, that will give us 10x, equals to this number multiplied by 10. Because this number is multiplied by 10, which is the same as 10 exponent 1, that means one of the 3's will move to the left. If it was multiplied by 100, therefore 2 3's will move to the left. So that means this number multiplied by 10 will be 3,3333 ... Let's call this one equation 1, and this one equation 2. And the final step is easy. You are going to take the second equation and subtract it to the first equation. You always want to take the second equation and subtract it to the first equation because you don't want negative numbers. Because I don't have enough space, I'm going to do this calculation in the next page. So what is 10x minus x? Because 10x and 1x are like terms, we are going to leave the x and focus on the numbers. We know there's invisible 1 here. So what is 10 minus 1? 10 minus 1 is a 9, and we leave the x the way it is, equals to, what is 3 minus 0? Well, that gives us 3. As you can see, the rest of the numbers will cancel because 3 minus 3 is a 0, 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 and so forth. Therefore, you have a simplified equation, and voila, now we have a simple equation. And to get the x alone, we are going to divide both sides by 9. Therefore, our final answer is x equals to 1 over 3. And that's how we convert recurring decimals that have a repeated single digit into a fraction. I hope that makes sense. Now, what about a decimal number that has a recurring pattern of multiple digits? It now gets interesting. Suppose you are given 5,432 with a bar, or you can use the dots if you want. To avoid confusion, this is the same as 5,432 4, 3, 2, 4, 3, 2 to infinity. And we call this a decimal number that has a recurring pattern of multiple digits. The steps are the same as the previous example. Step 1, let x be equals to 5, 4, 3, 2. 4, 3, 2. 4, 3, 2, ... Because this number has 3 repeating digits, using what we have learned about powers, that means we're going to use 10 exponent 3 because there are 3 repeating digits, which equates to 1,000. That means we're going to multiply both sides by 1,000 to move these 3 digits to the left so that we can cancel the rest. Like we said, step 2, we multiply both sides by 1,000. So what is 1,000 multiplied by x? It is 1,000x equals to this number multiplied by 1,000. That means we get 5. And the 3 digits after the comma will move to the left side since we're multiplying by 1,000. That means 3 numbers from the right must move to the left. Therefore, we have 5, 4, 3, 2, comma, 4, 3, 2, 4, 3, 2, ... And you will take the second equation, subtract it from the first equation. Let me go to a new page and show you how this works out. Now, what is 1,000x minus 1x? Because 1,000x and 1x are like terms. Therefore, we can leave the x and subtract the numbers. So, what is 1,000 minus 1? Well, that will give us 999x, which is equals to, what is 5,432 minus a 5? And that gives us 5,427, comma. Now you know that everything else after the comma will cancel. For example, the 4 will cancel with 4, 3, 3, 2, 2, 4, 4, and so on. The decimal will be 0, but we don't have to write the 0, so we will remove it. And voila! Once again, we have a simple equation. Therefore, to get x alone, we'll divide both sides by 999. And the 999 will cancel. Therefore, x is equals to, well, you can put this number on your calculator and it will give you 201 over 37. Or you can write it as a mixed fraction, which is 5/16 over 57. Remember guys, not all decimal numbers can be written as a rational number, because irrational numbers like the square root of 2, which is the same as 1,4142, cannot be written with an integer numerator and a denominator, because they do not have a pattern of recurrent digits. As you can see, 4, 1, 4, 2, the next number is like 1, 5, 5, 5, and so on. And they do not terminate, meaning they don't end. They go on and on and on forever. And this is what we learned in our first lesson. Thank you guys for watching. If you liked the lesson, please share it with your friends. If you have a question, leave a comment. I have no life, so I will answer all your comments. And yeah, I'll catch you in the next one.